We're talking about IoT today. A lot of interest. I'm Drew Davis, first off, with Cox. I am the Executive Director of Wireless Technology. That includes supporting our Cox 2M business, which is a IoT-focused startup business. The rest of my area, we're managed Wi-Fi services, but we also have wireless technology looking at CBRS, 5G, and a number of other technologies. IoT has been perennial exciting. It's always going to be next year, so hopefully we're here. It's this year for cable companies. We got two distinguished gentlemen. Joe Walsh is a managing director at Incode Consulting. It's just the strategy and consulting arm of Ericsson. His areas of expertise are focused on new technologies such as 5G, private network, and MVNOs, but he's also working with MSOs and MNOs on their IoT technology and market strategies. Joe's going to be speaking on leveraging licensed spectrum for LPWA, and he'll speak second. Also, Hani Beshara. He's director at Ericsson of Network Products. Hani's been in the industry for 20 years, holds a Master in Science and Systems Engineering from Southern Methodist University. Hani has provided end-to-end wireless solutions to a number of US and international customers across radio, core, OSS, BSS, CDMA, LTE, and 5G technologies. Lately, Hani has been responsible for market development and solutions for Ericsson's radio access network and Internet of Things for Tier 1 customers. Hani will be speaking on the evolution of cellular IoT. So we'll turn it over to Hani.
Well, thank you very much, Drew. I don't know if I should be speaking or maybe standing down there. I don't know if
you can
stand. Or not.
If you do want to stand down there, get that microphone off that stand.
I think that's probably the best way. We can use the clicker. Great. Yeah. Can you guys hear me? I guess it works. Excellent. Well, good afternoon, everyone. Hani Beshara from Ericsson. Very excited to be here, actually, first time. It's very impressed so far. Want to talk today about, I guess, cellular IoT and introduce the topic, especially for cable providers. I think this is an extension to what you have. Want to highlight how this actually differs in some aspects and what kind of use cases it adds. And you can maybe look into it from a business perspective and understand how would this fit into your business. All right, so I think that's the clicker.
No, it should be able to click from there.
Maybe down there. Let me double check. Oh, okay, it started moving.
Wait,
excellent.
Did it move?
Yeah.
Okay.
I think I need maybe to be closer to this.
Probably what it was, yeah.
All right, great. All right, so starting by just giving you a kind of a market outlook. So how big is that market for cellular IoT? If you look into the left side, cellular IoT or connecting devices over cellular, over GSM, started GSM days, if you guys remember, CDMA, this is not new. It's been out for a very long time, probably 15 plus years. In 2016, there was probably about 400 million such devices connected. By such devices, I'm talking, for instance, point of service, cash register connected. It's hard to get an actual wired connection. It gets wireless. Sometimes a GSM or CDMA, maybe 10, 15 years ago. Meters. A lot of meters have been connected using cellular, for instance. So 2016, there was maybe 400 million. The growth has been about 33%. It actually more than doubled. I think right now it's about 1 billion. It's exceeded a billion. And you can see it's actually, we're projecting, Ericsson has what we call basically the mobility report. It's actually a very well-respected report where every 6 months we give a forecast into what we expect in the future. We expect actually this to continue growing at about 22% a year, all the way to over 4 billion by 2024. So if you have a market that's growing at that rate, that's a really good market to be in, maybe one way to look at it. If you look into what kind of segments are growing, or you can look into the big ones at least. I would highlight a couple. Industrial, for instance. So industrial IoT, you can see it's the blue one. It's pretty large. So it's probably close to 20% maybe of this, or 25. Automotive is pretty large. And if you actually just follow on the, the tier one wireless providers, they actually are adding more cars, connected cars, than devices today. So that's why you see those numbers pretty large as well. Utility is also good. And then if you take that and link into how big is that business dollar-wise, you can look into the right side. And I chose those three specifically because their value is extremely very large as well. So those are kind of the very good return if for anyone who actually takes on those specific segments from cellular IoT perspective. It's that the whole market is expected to be over $600 billion by 2026, as you can see here. So I think the message is this is very large. When Ericsson looks into cellular IoT in general, we actually try to segment it. It's not all devices are created equal, not all use cases are created equal. So we see about 4 segments. One of them is the massive IoT. By that, we're basically saying those are devices that are usually very simple devices. They need to send very few bytes a day, and sometimes maybe a few bytes a week or a month for that matter, depending on the use case. But there could be millions of them. So that's why we call it massive IoT. And that's one category. Then you have really actually what you see today is a lot more of the broadband category, which is basically your connected car. That would be the broadband category, right? And depending on whether you want to do it with, depending on how much throughput you need, that actually 4G and 5G would both fit in this category. Then we look into another segment, which is the critical IoT. Critical IoT is really about the ultra-reliable low latency communication type of use cases. Meaning, when you start looking into the energy grid, for instance, right? Protection is needed. It needs to be ultra-reliable. You actually sometimes have wireless and multiple, sometimes it's a microwave and you have multiple links that back each other. So it has to be very high reliability. The latency, usually in those use cases, have to be very low. By low, I'm talking usually 10 milliseconds or lower for that matter. We cannot do that today in wireless in general, in LTE, for instance. Usually, I would say it's about over 10. Most networks are 20 plus. The last category is what we call industrial automation IoT. And this is looking into the factory. The factory today is mostly wired. Why? Because basically, most of the protocols used, there's things like Profinet, and those type of protocols are Ethernet-based. They are all usually wired. And that is a restriction that is gonna change at some point, because really the only way to really go through an industrial revolution is to really unwire this factory. Why? Because it's pretty inflexible. When you need to do any retooling in a factory, that's months worth of downtime. It's not, basically it's an area where it's really can result in a huge benefit to the industry, and that's where tons of billions of dollars can actually be gained if we unwire the factory and enable Ethernet to go over 5G. So it's really about encapsulating 5G, encapsulating Ethernet, and specifically probably the time-sensitive network type of protocols, which is usually IEEE 802.1. Those protocols, which is Ethernet-based protocol, encapsulating that in 5G will really help unwire the factory. So those are the 4 main categories. You can see some use cases. All right, so talking about, yes?
On that slide, when you say a new radio there, does that imply like the 5G core, or just, like now it seems like most of the new radios radios are on the LTE cores, and then, but in your slide, should we read that as full 5G or just the new radio, and then with the LTE core is fine?
No, you're right. When we are talking critical IoT, for us to achieve this very low latency, I think the new core will be needed. So that would be 5G core, not 5G EPC, which is really what you're saying when you have dual connectivity and just upgrading the EPC as is. Yeah. So
both of those in NR cases, you would want 5G core?
Correct. I think NR would be needed definitely, and 5G core in critical and industrial IoT as well. Okay, so massive IoT is already here. This is talking about enhancements that happened in 2016, enabled narrowband IoT and Cat-M type devices. Those are two protocols that came on top of LTE. It's a software upgrade from an LTE perspective. And that's why it actually was very simple to deploy. Today, there's more than 80 networks in the world that are actually Cat-M and or narrowband enabled. So just one software upgrade, you enable cellular IoT, and it's either narrowband or Cat-M basically provides a little bit more throughput to those IoT devices. So two different things. What it gives you, why is this different than LTE? Because it builds on top of LTE. You can see the benefits right here. Gives you coverage extension. Battery life goes up to 10 years. This is cheap devices, relatively, or let's say inexpensive devices, because obviously this is relevant definition of price. Narrowband IoT is today, usually you can buy a chipset and a module for about $5, and we expect it to continue to go down. So it is inexpensive, I would say, especially compared to normal LTE or 4G devices or 5G devices. It's going to be way more than that. So that's the first category. It's here. And as of maybe a year or two back, actually that segment started to take off from number of devices deployed perspective. It's actually led to great extent in China, for instance, in Korea. That's where numbers are larger. But even in the US, numbers have started to go up. Just lately, the number of devices now that are using narrowband exceeded GSM. So that's kind of, for narrowband, GSM was the solution until, I would say, last year. And then narrowband overtook that. The next segment, which is the broadband segment. So that's your 4G and 5G. And while it's not different at all than your normal wireless network with LTE or the newly deployed networks that you start hearing about with 5G, it enables a good number of use cases. And actually, most IoT use cases today, especially the ones that have high return, and by that, I mean, for instance, a connected, if you go in transportation and you have a truck that have a Cat0 or Cat1 device, for instance, like an LTE device, that's a good $70 or $100 a month bill still for any of the tier ones. So they like this because it actually has good return. The Cat-M and narrowband IoT devices, those are usually, the subscription is very low from a cost price perspective. And you can see online, for instance, there's plans that are, a year is, for instance, $15 for the whole year. So when you look into high value, low value, Cat-M enables, broadband with 4G and 5G, that's high value use cases. Okay. Type of use cases, a lot of those are starting to really happen. Things like related to drones, for instance. That's a lot, not just trials. I think now you're starting to see someone going beyond one-off into actually wanting to deliver a service in a small area. Amazon is starting to go in that direction. Actually, the postal office is also looking into that, for instance. So those are use cases that are trying to use the technology in a different way, which is basically pretty interesting. You can see, obviously, health monitors, smartwatches. Those still want relatively good throughput, and that's why they didn't really fit in the narrowband and Cat-M, although it's a small screen, but the user still wants good experience. And that's why it's really kind of becomes a 4G, although on the low end of a 4G device. What this one does not provide, as I said earlier, is it's not very low latency, but it is good throughput, right? It's a relatively low latency compared to some of the massive ones, but not very low latency. So for critical IoT, and by that we usually mean ultra-reliable, low-latency type communication. When we say ultra-reliable, I remember back in the wireline days, we used to say we need 5 nines reliability, and it translated to about a downtime of a little over 5 minutes a year. So a network should not go down more than 5 minutes a year. That's wireline numbers. When we take it into ultra-reliable, it's actually 9 nines, and 9 nines is actually a fraction of a second a year. So this network needs to have reliability, where reliability translates to it's a multi-link. It's every packet delivered needs to be duplicated, and depending on the case, that may be done even quadrupled. So reliability comes at a cost, but those networks basically deliver a very high value, and it's used in use cases where it's a life and death situation. As I was saying, like things related to, for instance, the utilities industry, or it is related to the smart grids and renewables and so on. So this is a new segment. I would say the industry is moving in this direction, but it's not there. So the lower latency part has actually, from a standards perspective, is coming along. There's actually, if you look into the roadmaps of the different OEMs, you'll find us providing a lot of enhancements and features to lower latency. 5G in general actually provides an architecture, end-to-end architecture that can help lower that latency. So I think latency is in much better shape, but when we start looking into reliability, there's actually a lot more work to be done in the standards as we build the reliability to what we're saying, the 5 nines we're talking about. For us to be able to put it in a smart grid where basically supply and demand in a power station, we would trust it that if the demand goes down, we will be able in milliseconds to take supply down, otherwise you actually have explosions. So this type of use cases and reliability, I think we're not there yet, but we're working on it. And it starts at the standards, and then the OEM starts adding enhancements and features on top of it. Manufacturing, that's actually also, I would say that's the last segment, and that's the one that is even more difficult. Time-sensitive networks is an Ethernet, basically protocol enhancements, I would say, under IEEE. And that's the prerequisite, and that's undergoing actually it's evolving on its own. And the next stage will actually be encapsulating that in 5G. So you can see from what it would really imply is that this is Ethernet support, time-sensitive networks, and local area non-public networks. So this will also, you'll see this, for instance, in a manufacturing facility. We expect private networks to actually start moving from, today usually it's either wired and you can see some Wi-Fi in a manufacturing facility. That starts moving into cellular and unwire the factory completely. And when we unwire it, we're still supporting the same requirements, but over 5G. All right, so this is, for instance, shows you, if we look into a smart factory, all the different types of use cases that can fit in the factory and how they would be either, what type of segment it is. So you can see how this translates from a use case perspective. For instance, AGVs, automatic guided vehicles. So those are the robots that are moving along, a certain path, for instance, inside the factory. And those today are actually wired, which is a challenge on its own. Obviously, it's inflexible, and it basically means you cannot, if you have a vehicle that's wired, that's, in my opinion, it's just counterintuitive. But that's the type of thing that needs critical IoT. So again, it's back to, it's very dangerous. It has to have very high reliability and very low latency for us to be able to unwire that one. Collaborative robotics needs basically the Ethernet enhancements. Inventory management, that's relatively easy. That's a lot of tracking. So that's more of the IoT, massive IoT side, tracking logistics. Audio video could be security systems. That would need basically higher throughput with the 4G and 5G. So you can see how a factory, for instance, with so many use cases inside the factory and how it fits within those 4 categories that what we're talking about. Just expanding on the same concept, giving you, fleets, managing fleets, that would imply supporting, it needs high throughput. It's also massive IoT. It's sensor sharing. There's a lot of different use cases, and we're just trying to show which one fits in which of those 3 type of categories. So having said that, so what does 5G give us? So get back into, why is 5G going to really change the equation to a great extent? So 5G is a single network, right? And it's a single network that would be able to support all what we have talked about, right? It supports that enhanced MBB, and I mean, even there's another session here that talks about how you can support 4G and 5G at the same time. We also have, it supports the massive IoT, the broadband, the critical IoT, the industrial automation. Now all of that with a single network. And then when you use network slicing, and network slicing is a concept that basically, if you have a pipe going from the radio access network, the access, into the core, and you want to guarantee performance, you need to partition or slice this pipe to make sure that if the traffic increases on a lower priority use case, it does not take resources and does not impact the performance of a higher priority or an ultra reliable low latency communication use case, for instance. So slicing is a very important component of that, and that is one of the important things that comes with 5G, network slicing and the 5G core, that brings that concept here. So overall, you can see throughput increases by 10 to 100 times. And obviously, throughput is a factor of what spectrum you're going to use. And with 5G, it introduces very large amounts of spectrum, for instance, in the millimeter wave, which would be great to use, for instance, in a factory if we're going that route. Obviously, that does not have to be everywhere. Usually, if you need coverage, you end up in the lower spectrum. If you need extreme capacity, then you end up in the millimeter wave. But it's a network that's flexible enough to be able to support both at the same time. So from a cellular IoT perspective, just to summarize, we're able to, today, we have massive IoT, and massive IoT is here growing at a very large rate, 33% and now 22% will continue to grow at that rate. The broadband IoT supports a lot of different use cases, whether it's 4G or 5G. And in the future, we're getting basically the critical IoT and the Ethernet support with industrial IoT. And cellular IoT in general, because of it is licensed spectrum, it provides a value in guaranteeing the grade of service. And it's something that doesn't necessarily fit every use case. There's a lot of use cases that can be happy and can run well in the unlicensed space. But obviously, you can also see out of what we talked about how licensed and guaranteed performance is also important for many, many use cases. Questions?
Narrowband IoT, is there one of the advantages I think why it's so cheap, they don't have the user plane, or it goes right through the MME, and do they have that same kind of narrowband concept in 5G, or is there narrowband IoT for 5G?
Excellent question, actually. So the answer is yes, and it's called the Narrowband IoT, meaning Narrowband IoT as a use case will continue to support it in 5G as is. So it becomes effectively a 5G technology where you can support a narrowband, small narrowband channel within the 5G spectrum or within a 5G carrier. So the answer is yes. And especially if you're starting today with any narrowband IoT use case, you want to make sure that this use case would live for 10, 15 years, even if you move out of LTE into 5G. And the standards is ensuring that that would be the case. So narrowband IoT will continue to be supported in the future.
Does it connect to the UPF or the SMF, or does that the same type of concept where it avoids the user plane?
The way we see it, the question would be, if you have a use case and a narrowband IoT that's already running, why change your core? So right now the view is that you can continue to support the EPC as is today in support of the use cases of today, especially in the narrowband side. You don't need to make a change per se.
And we can hold questions
Towards the end as well.
and make sure we get Joe in. We'll have time and hopefully have 15 minutes at the end. You want to walk? Okay.
So we can,
We could just set up.
just use the, excellent. Technology, we'll get it down. So just a real quick little tweak to Drew's introduction. I am going to talk a lot about cellular, but I'm really going to talk about it as well in the context of unlicensed and other technologies. I'm a huge Star Trek fan. I love Scotty. I love it when he says, use the right tool for the right job. So I'll be talking a lot about really going through that. I'm going to be a little bit more on the business and the tactics side, because if you don't have the rest of your company behind you around IoT, it's going to really make it really challenging to be successful. And just really starting out here, if I'm going to do this right. I think we can, we may disagree on what the actual number is, but we can all agree that there will be billions of devices out on the network, and it is growing quite quickly. I think probably the hidden secret that we all know but we hate to admit is that connectivity, when you start talking about the value chain and how much that's going to play, is actually a relatively small part. Really getting down sub 10%, probably in the 5 to 6% range when you start talking about the overall IoT marketplace. Really where a lot of the drive and the power really comes behind the revenue generation. It gets into the applications themselves as well as the services around IoT. Now, the good news and the bad news is that the partnership capabilities to be able to get the applications on board. There's lots of models to really be following behind that. And from a services standpoint, really the MSOs with having field service organizations and already having an expertise in managing that have a little bit of a leg up in terms of trying to expand out the business model. The downside is those are generally in separate organizations inside of the company, and trying to get, again, the whole organization working together can be a little bit of a challenge. So one of the first things, obviously, is thinking about the network technology, and there are absolutely very valuable use cases for any one of the technologies. And while I show a very lopsided balance bar here, I really like to look at it as the tendency for these solutions to go one way or the other. And so if you look at something like farm operations, things that are in rural markets, typically very spread out, where you may have limited cellular connectivity. And at the same point in time, you may not have the 100% urgency of, hey, I absolutely need to get this message at this second. If you get the water sensor a few minutes later, it's not as big of a deal. Those types of applications are probably fertile and will probably, pardon the pun, go more towards unlicensed spectrum. That being said, I think if you were at the panel yesterday where Charter was talking about one of the proof of concepts that they were doing, it was very much a HetNet kind of an approach, where they were using LoRa to get out into the fields and even into some of the grain silos, where you have very low volume type applications. They were using Wi-Fi inside of the farms in order to be able to do video applications. I think the particular farm they were looking at was a hog farm. So being able to have the video and seeing real-time monitoring was one of the critical requirements for them. And then they were using more LTE spectrum to backhaul off the farm back into the network. So there are definitely a lot of use cases, but I think when you start looking at some of the lower volume, particularly when you're out in the field with moisture sensors, something like LoRa is a great use case for it. It's very easy if you don't have the coverage. Putting up a LoRa gateway works out very well. I think we will start seeing NB-IoT encroaching into those areas because, again, it's also great for low latency types of things. And I think as the rural coverage picks up, NB-IoT has some advantages which gets you a little bit longer coverage. And it just simplifies the implementation that much easier. Asset tracking is probably something that's kind of based on the actual end user use case. Obviously, if you're looking out at something where you need to have global coverage, cellular is going to probably end up a little bit more prevalent in that case. If you're looking at in-building coverage, there's a lot of great use cases for logistics companies actually putting in private LTE and in-building coverage solutions that get relatively accurate cellular locations. But this is one of the areas that now, until those things really become much more prevalent, a number of companies have been thinking about unlicensed technologies to be able to get some of those location capabilities. Again, it's going to get down to how critical it is in order to know the exact location at a particular point in time and where that device, where that asset is and how frequently it moves when you start thinking about which direction to head. Now, when you start getting into something that's really relies a lot on knowing exactly when something happens at a specific point in time, and I use the case of public safety as the example, having the licensed spectrum means you have a lot more control over the QoS. You know that if you have a device that's prioritized at a certain time, you can allocate the spectrum for it to be able to get that back. Some great use case examples of this. Samsung and KT just launched a big initiative for Korea's public safety network. And when you start talking about massive IoT sensors, one of the things that they are looking at are things like fire sensors that get distributed around, being able to pick up signs of fire much quicker to be able to speed the response times there, are some of the areas of where they're looking. So I think when we start thinking about the U.S. in terms of that mix of technologies and spectrums and what companies are using, I think the U.S. operators are they've paid an awful lot for the spectrum they have, and they're really sticking firm to that. Internationally, there's a little bit more of a chance to experiment, having both licensed and unlicensed. I think one of the good things, and probably, in the U.S., T-Mobile was probably one of the early proponents of getting NB-IoT put out in a nationwide effort. I think they were probably a little surprised at how quickly the rest of the carriers fell in with that. The great thing with that is that you do end up, and they will have an advantage when it starts coming to the ecosystem in terms of devices and interoperability with the devices. Hani had said that the prices now are about $5. It's a little bit above what a LoRa chipset is going to be, but that price is going to continue to come down. And when you start looking at applications and application developers and what they're putting out, you start getting a little, the scale effect starts taking over. So I think it's going to be really important as you guys start thinking about deploying out IoT, making sure that you're picking the right use cases and the right market segments for the technologies that you're going after. So I think just to step back for a second and level set of the traditional IoT value chain and where some of the profit pools are. We generally think about the device hardware, the software that's on the device, obviously the connectivity, the cloud platform that's managing all of the connectivity and device management and everything, and then the analytics and the application. I add in, and I see a lot of people doing this as well, of adding in security, and I don't put that in the value chain because it makes it sound like, oh, well, when I get to that point, I start thinking about that. One of the key things that will be important for all of the operators is thinking, and application developers, is thinking about security from the get-go. When you sit down and you start talking with the customers, start thinking about what security means. When you're talking to the device manufacturers, think about what the device means and building it from the ground up. And I think you'll start seeing that the marketplace is starting to respond to this. One of the things that we've been testing out in the IoT studio out in California is really working with Microsoft's Sphere product. And one of the big reasons why is because it was built from the ground up as a device with security connected all the way through to the cloud. Taking advantage of some of these things is really important. I think the 3GPP standards, give a little bit of a natural comfort layer because the security is also built into those. And I think a number of new, initiatives that are coming online for, specifically for NB-IoT with things like non-IP data delivery also help out a little bit with making sure that it gives you additional options for building and security. But in addition to that traditional value chain, we've been telling operators now for the last 3 or 4 years, is that partnering needs to become a core competency. And you need to think outside of that traditional value chain. A couple that I'll pick out here, I talked about services as being really important for IoT. This is particularly true for enterprise IoT. It will be very important to make sure that you're matching up with, companies that do have some of those large service capabilities. I have here, IBM on the list, but there's a lot of them that are out there. This is something that can be used either in lieu of or in partnership with your own, field service forces to be able to solve a lot of the problems of enterprise IoT. One of the other ones, enablement platforms. This is the Amazons, Microsofts, Googles of the world. On one side, they're going to be your best friends, and the other side, they're going to be your worst nightmare. Clearly, if you take a look at what they have from an IoT platform, they have many of the capabilities around device management, analytics, the data, all of those types of things. What they lack, though, is connectivity. And connectivity management. And that is a big option to be able to try to, to tame that beast. The part where you do have to be a little concerned is, just this past week, Amazon has come out with a couple of major initiatives around IoT. One of them, Sidewalk, is supposed to me, it's kind of like a LoRa Lite, kind of an approach, but given, you tie that in with their ecosystem, as well as they have a device connectivity, an Alexa connectivity kit, which basically is a Bluetooth Wi-Fi chipset easily integratable into whatever IoT device that you're working on. Oh, by the way, it also comes with Alexa integration, integration into Amazon's cloud services, and some device management capabilities. So they can definitely be a friend, but they can also be a foe as you get into this. And then lastly, depending on your strategy, that you're going to market with, you do need to be thinking about, some of the other OEMs that are in the players. A lot of the things that Hani was talking about in terms of the enterprise IoT, a lot of those really get enabled by, compute and storage and edge compute, on the factory floor and things like that. That are definitely valuable and taking advantage of some of those as well. Just really quickly here, and I'm not going to spend a whole lot of time on this, but the different approaches that the different carriers are taking. I think AT&T is probably a good one to study for a couple of different reasons. One, with AT&T Foundry, which is their open innovation program. They started out early when they launched the Foundry in 2010. M2M at the time was a core central component of it, and they spent a lot of time making sure that any of the companies that were coming into the Foundry, they had design support services. They even went through and pre-negotiated contracts, not only with module manufacturers, but also with some fab companies, that they then turned around and opened up to all of the startups that they were working with. So they were, again, trying to lower some of the barriers to bringing new products onto the AT&T network. They also have their AT&T consulting group that specifically goes out and works with enterprises on their IoT. And again, providing a little bit of the services of, hey, what are you trying to do? What's, how do we put this all together and put it on the AT&T network? So I really like some of those things. One of the common denominators across all of these experience centers, particularly when you're talking about enterprise level IoT, making sure that people can touch, feel, kiss, whatever, the products really goes a long way to securing some of those customer relationships. And I'll just spend a couple of, probably 2 minutes on something that I've really been working on the last few years, and that really is around the open innovation. And how do you get companies to kind of come in and work with you on your on IoT products to be able to get out and launch. One of the areas that I'm particularly passionate around is co-creation. And that is sitting down with your partners and with customers and really going through a design thinking process of what is it that we're trying to build, what is it we're trying to do, and leveraging a bit of a rapid innovation process to make sure that you can get a prototype into a customer's hands that they can then trial out before you actually make the decision to commercialize. And this may sound like it's, actually it does sound like it's a hippy-dippy California thing, but really the major, the Fortune 100s are, really starting to fall into place with this. And if enterprise IoT is on your roadmap, you don't have to go full bore co-creation, but it is definitely something to be considering about a capability to build up to be able to launch in. It's great. It helps you multiply your capabilities. You're bringing your partners into the, in at the get-go. You're bringing the customer in at the get-go. One of the things I loved about that charter presentation earlier is they said, "Oh, we sat down with the farmer and asked what is valuable, what is it that you need before really approaching the rollout and everything else." And so you get a chance to capitalize on that feedback. Yeah, you're going to go through this process and you're going to, kill off a bunch of things. But at the end of the day, hopefully you have a stronger product portfolio coming out of the backside of it. So I'm going to stop there so that we have time for questions, because I always love the interaction on the panels and everything. So we'll go with that.
Yeah, I've hosted a number of panels. This is very rare that we actually are on schedule. We have 10, 15 minutes left for questions. have some prepared, but does anybody have any questions to start? Yeah.
What early signals are we seeing for pricing accretion from that $15 per year IoT device when you start to layer on ultra low latency, high bandwidth capability, and high reliability?
Do you want to take it?
I'll take a crack on it.
Go. And then I'll disagree, and then we'll have a fight.
That sounds great.
We're going to make it entertaining.
More interactive. so the $15 a year for the massive IoT type of price is that's definitely for a small amount of data, and it's something that's probably, I would say, the bottom feeders, right? And what we see is that not everybody's actually going after those type of use cases and those customers as much. What we're seeing from a pricing perspective is that everybody's going over, after the higher value ones. The ultra reliable low latency communication will actually not be an attrition. We expect the price to probably per bit to be maybe even 100 times more for that type of use cases for ultra reliable low latency communication compared to that of the massive IoT type. What do you think?
Yeah, no, and I mean, I kind of look at it as, what are the use cases and what's the value that's being driven out of it? And, I had a chance to interact with an auto manufacturer. I guess I can say I had a chance to go to a Porsche factory. Now, that was pretty damn cool. And really talking about, what is the value around IoT? And in this case, because it's inside of the factory, it's synonymous with private LTE. And they're building a brand new factory. And, I was kind of being a little provocative, and I'm like, come on, you guys really don't have a business case, to support the 5G rollout you're talking about. And, the guys really opened up at that point in time, and they said, let me just talk to you about the building of our new factory. Traditionally, we would have to trench into the building construction. And trench places for the machinery to be able to move the car chassis around and all like that. We're doing everything on autonomous guided vehicles. So off the get-go, they're saving tens of millions of dollars. That's just on the construction cost. And when you talk about, okay, now once you're in the factory, what else can you do? Now that you have this flexibility, they showed us the assembly line, and there's this one station where the assembly line kind of dips out and goes back in. And he's like, yeah, that's where we installed the dashboards. The guys who were working there said, hey, it would be great if we had an extra 1.5 feet to be able to get the dashboard into the car. And they said, okay, no big deal. They move it out. They start talking about what it costs for them to, load in firmware. And right now, a car has about 50 megabytes of firmware on it. They're expecting that to increase 10x over the next 5 years, for their new models. If it leaves the factory without the latest firmware, it costs them, I think they had a recall where they spent $20 million just to be able to do that. So all of these things are being able to be enabled because they fully embrace, IoT and the private LTE inside of the factory to be able to make it happen. And so those things will mean, hey, I'm not paying per bid. I'm not paying the $15 per connection per year. I'm paying X dollars for this capability, and I'm saving Y. I'm good with it.
Yes.
So there are a couple of issues, I think, that are probably unresolved at this point. One is that, let's take your Porsche that leaves the factory and it's now an autonomous vehicle that's on the road someplace. It has two issues. One is low latency communication to cloud, which might be solved maybe with distributed architecture like Outposts or something like that. But the other issue is going to be carrier connectivity and permanent roaming agreements, which don't really exist today in a cost model that works on a per device basis for IoT. So what have you guys done with regard to that kind of huge problem?
Are you working on that? That's edge computing.
Yeah, I mean, I can talk maybe about a couple of things. So on the latency side, I think there is work like 5G in general, based on the architecture, and also depends on if the requirement is to have very low latency. Going millimeter wave subcarrier spacing would allow 1/8 of a millisecond, for instance. So technology in 5G would be able to bring down, together with Mac, mobile edge computes, you're bringing everything to the factory. If we're able to do that, then latency will be low. I think that's doable. It's in our experience right now is networks would be LTE networks can achieve 20 plus, and a perfect one maybe 10 milliseconds actually. But with 5G, 5 milliseconds or even lower. And I think standards is also evolving to even reduce that number. The goal is to go below 1 millisecond. That's one part maybe of your question. I think the other part about roaming, definitely a problem. We saw the first roaming agreement actually just a couple of weeks back where Rogers in Canada, I think, established the roaming agreement with the US, with the, I'm not sure if Verizon or AT&T, but they now actually have cellular IoT roaming between Canada and the US, for instance. But definitely it's not global. I think yet would be probably the answer. I can see someone like AT&T driving that. If the need and the use case come, that would make sense. I can see them driving it, but I think it's still challenging. And back to your comment over it's going to be expensive. Maybe that cost model will not be very good. I agree. That's going to be a challenge. We're going to have to wait and see where it goes.
Thanks.
Yeah, I would just add to that. We see the same problem at Cox, where even if you're trying to cover a bunch of areas rural, some places one carrier is there and others aren't, and same other places. And it's all the carriers today still have you buy, a narrowband IoT device, it works on their network, it doesn't work on other networks. Well, and then that adds to the cost of the device, and even if it's eSIM, it adds to the complexity. So we're definitely struggling with that. I think the focus, and you see a lot on IoT is premise-based solutions, and we're having initially a lot of luck with premise-based solutions. A lot of the value is in deploying the application on the premise. In the sense, same with that factory, is the value is they want a premise solution. They're really not truly operating on a mobile network, right? It's really almost like replacing Wi-Fi more than replacing mobility.
I was just going with this portion model.
Mm-hmm. Yeah.
Well, but that one, what I was talking about absolutely was premise-based, but I totally agree with you 100%. For the cars themselves that are out driving around. Yeah. No, and the autonomous vehicle, I think there's a lot of
physics
There's
issues
a lot of
there.
work that has to happen on it, I think, for the...
But is 3GPP looking at like open kind of, like for IoT, that there would be some type of agreed to structure for roaming, like where it's inherent and it's like a revenue share or something? I don't know how they would do it, but is that
usually
is the business issue being looked at?
I don't think 3GPP is looking at the business side of it. Standards allow it. It really becomes a business model.
Yeah.
Like the companies like Edge Gravity and these other service providers that will create edge cloud data centers that will support those type of things in a non-carrier environment.
Yeah, I think the edge compute and how it rolls out, that's the huge question right now. And, you have, the ideal situation, unfortunately, is illegal for all the carriers to get together and say, hey, let's do this once. And so it's going to need a lot of business finesse in order to make those relationships between the carriers for the edge compute roaming to be able to work out properly. And at the same point in time, you got to make sure that the big guys in Seattle are not encroaching too much as well. So.
Yes.
How do you see LoRa deployment going? I keep hearing about LoRa and the proprietary nature of LoRa. Do you see that holding back growth in that area?
Yeah, I was having a conversation with somebody this morning. I'm like, remember when I told you 2 to 3 years ago that LoRa had a 2 to 3 year window to operate pretty much with impunity to do whatever, and you got to run real fast? That actually is really playing out. I would have loved to have seen it go faster. And unfortunately now the operators are getting their act together around LPWA and NB-IoT and LTM. They're all starting to come online, so it's going to be a harder slog for LoRa. There will be absolute 100% use cases where LoRa will win, and you just need to make sure that you're picking and choosing. If LoRa's your horse, pick and choose wisely and go for them.
The guys in Seattle like LoRa?
Sidewalk is unfortunately too new to really say what's going to happen with it. I don't think, I guess if your question is do I see LoRa disappearing in the next 2 years like Betamax? No. I think there's lots of use for it. Sometimes if one person in Seattle does something, the other person will do the exact opposite. So there could be opportunity there as well.
All right. I did have one question. We talked about the uptake. I mean, the largest kind of network that was GSM based is fleets. A lot of them have been migrating to Narrowband IoT. That's a lot of the growth. It's really just migration, right? From other than kind of those large fleet, vehicle deployments. What applications that aren't premise based that are more, what's really taken off in IoT that you see as like really a killer app for IoT?
Yeah, good question. I don't think there's only one killer app per se, but I think there's always surprising apps that actually ends up, with a large volume of devices and actual deployment. The first interesting one happened in China, actually, as soon as Narrowband was deployed, was their bike rental type application. So bikes left on the street, they put on it a Narrowband chip, and basically it's wireless, so you can swipe your phone and rent a bike on the spot. It was an interesting one because actually they need to know, for instance, like the actual location.
Scooters. This is a cool crowd. They use scooters.
Scooters, not bikes. China's so between bikes and scooters. So that millions of devices was actually deployed that way initially in China. In the U.S., it's a variety of different types of use cases. On the Cat-M initially, I think both AT&T and Verizon started there. First one for actually AT&T was, the what do you call it, the Amazon button, was it? The dash, yeah, the dash button. So AT&T had on Cat-M the button where you can use for anything. You can put in a bathroom, and if someone pushes the button, it means you need help in the bathroom. And it has very good connectivity because it's extended the coverage, battery life, and so on. Basically, it's they sold it, I think, for I think $30 for 3 years. So it's just a one-time fee, and that's the model for Cat-M and Narrowband. In many cases, is not a monthly fee. Right. It's a one-time fee. I've heard of other applications where, for instance, some of it are even replacement for Wi-Fi sometimes. One interesting example was, for instance, the water heaters in the attic connected with Narrowband as opposed to Wi-Fi. I think some of them actually come with a Wi-Fi module to basically, it's to send the signal when there is an issue or it's water leaking. So Narrowband, for instance, would apply in that. One of the benefits also for Cat-M is voice support, actually. And there is a number of security companies looking into support with voice. That one is interesting because I think usually the coverage for voice is not equal to LTE, it's actually less. But as I was saying, it's really, there's a lot of use cases, and I wouldn't say it's a single, particular app, but ideas come. I would say there's probably hundreds of proof of concepts, and some of those would, make it through. Yeah.
Great. Yeah, and I guess I would say some of the things that'll, start appearing, and I agree, it's not going to be any one thing. Tracking stuff is going to be a big deal. Pet trackers, Samsung came out with their tracker, which is a little Cat-M. It's a little big, a little pricey, but I think that's a kind of like their first try kind of thing. I'm personally waiting for the tile killer of something that's going to be a little bit bigger than tile, but I'll work on NB-IoT and work everywhere. You know, pricing points can certainly get down to make it really competitive. And I think that's where, you know, if there's anything that's going to be really holding it back, it's kind of the pricing and getting the pricing right from the national carriers. They've never met a, I'm trying to think of a polite way to put it, but I think sometimes there's a tendency to really load up with some of the national carriers on that. And I see the great opportunity for somebody disruptive like a T-Mobile or a Sprint and saying, look, all of your consumer devices, 10 extra bucks a month. I don't care if you have 1 or 50 of them, great. You know, put them on there. We'll put it as part of your account. And that'll be, you know, an aggressive strategy for them to go through.
Very interesting. Okay. I think we've run out of time. Appreciate everybody's participation. Appreciate your guys' work. Very good presentations. Really enjoyed them. Thank everybody for coming out.
Good to meet you, sir.